Good morning, all of you. So, in today's class, we will learn thin prism, then dispersion of light. Okay, thin prism and dispersion of light. So, let's start from thin prism. Thin prism. So, prism and thin prism. What is the basic difference? The difference is the angle of prism is small in case of thin prism. That is very, very small. So, let's draw the diagram of this thin prism. I am drawing just normal diagram, but its angle is very, very small. These are the two normals. You can draw with protractor whatever these angles, right? So here this is I1 and this one is angle I2. This angle is R1 and this angle is R2. So if we will extend this ray, that is incident ray, like this, then this angle is your angle of deviation. This already we have learned, but still I am giving you. This is I am denoting with dotted lines. Okay, this angle is what? Angle of deviation. So this is P, Q, R. This point is S. This point is, let us suppose, T, and this is something U. Okay, this point, and this is your angle of prism. I am denoting with angle A. These are the two normals, N1 and N2. So this is a medium one. So this is suppose air, and its refractive index is mu1, which is equal to 1, and this is some other medium. So let us suppose glass or anything. So this is having, let us take it as a glass, and this is suppose mu2, this is equal to mu. Okay, so let's start now. So we know angle of deviation delta is equal to I1 plus I2 minus R1 plus R2. I1 plus I2 minus R1 plus R2. This is what angle of deviation formula. Now, at point S, at point S, see here mu1 sine of I1 is equal to mu2 sine of R1. Mu1 is what? 1. So therefore, sine I1 is equal to mu2 is mu, and this is what? Sine of r1, right? Sine I1 is equal to mu times sine r1. Call this equation number 1. Next one, at point T, at point E, at point capital T, what we are getting? Mu2 sine of r2 is equal to mu1 sine of I2. So mu2 is what? Mu. So here you are getting mu sine of r2 is equal to mu1 sine I2. So mu1 is what? Mu 1. So sine of I2. Call this equation number 2. Okay. Next, after this, for small angled prism, if angle I1 is very small, then sine of I1 is nearly equal to I1. Yes, sine of I1 is nearly equal to I1, and sine of R2 is equal to R2, and sine of R2 is nearly equal to R2. So therefore, equation 1 becomes, what we will get? Sine I1 is equal to I1. So, and sine R1 is equal to what you will get? R1 only. Yes or no? Similarly, same thing. I2, sine I2 will become I2 only. Yes or no? Right? Similarly, here even sine of I2 will be nearly equal to I2, and sine of R1 is nearly equal to R1. Okay. So equation 1 becomes sine I1 is I1. So therefore, I1 is equal to mu R1. Call this equation number 3. And equation 2 becomes, this is mu R2 is equal to I2. Call this equation number 4. So substituting this in equation, let us suppose capital A. So I am denoting this as equation number A. Okay, first one. So here, what you are getting now? Delta is equal to I1 plus I2. I1 is what? Mu R1. So therefore, mu R1 plus mu R2 minus R1 plus R2. Now R1 plus R2 is what? A. So here it is mu common R1 plus R2 minus R1 plus R2. But we know R1 plus R2 is equal to A. We know what we know, R1 plus R2 is equal to A. So therefore, delta is equal to mu A minus A. Mu A minus A. So now if I am taking A common, then what you are getting? Mu minus 1. So this is what your formula for angle of minimum deviation for small angled prism. Delta is equal to A into mu minus 1. Understood? So let's solve one small problem on this, which is they are asking for 2 marks. So let's see. IP they are asking for 2 marks question on this topic. So what is that problem? A small angled prism of 4 degree. A small angled prism of 4 degree deviates a ray through 2.48 degree through 2.48 degree. Find the refractive index. Find the refractive index of the prism. Find the refractive index of the prism. Okay, this is what the question was. So first one, what is given here? Small angled prism means A is equal to 4 degree. Next they have given delta. Delta is equal to what? 2.48. And what is our formula? This one. But what he is asking? Mu. So mu is equal to question mark. So just use the formula and do it yourself. Try to do. Delta is equal to A mu minus 1. So delta is 2.48 is equal to 4 into mu minus 1, and therefore mu minus 1 is equal to 2.48 by 4. 2.48 divided by 4. So this is how much you are getting? 0.62. And as mu minus 1 is equal to 0.62, so mu is equal to 0.62 plus 1. So you are getting answer as 1.62. This is what your refractive index. Understood? So note down this. First is this page. Draw the diagram, try to understand, and then this problem. Okay? Do it yourself and note down. Okay, finished. So let's move ahead. Next one, dispersion of light. Dispersion of light. So you know what is dispersion of light? Dispersion of light definition is what? Simply splitting of light into its constituent colors. So what is this? Splitting of light into its constituent colors. And why this is occurring? This occurs due to the fact that refractive index varies with wavelength. Refractive index varies with wavelength. This occurs due to the fact that refractive index varies with wavelength. So how it varies? How it varies with wavelength? So I'm writing one line here. You see, as the refractive index decreases, wavelength increases, or wavelength increases, refractive index decreases. Wavelength in bracket lambda increases, refractive index decreases. Refractive index decreases. Refractive index is divided by what? Mu. So we can write in the bracket mu. So here it is mu. Mu decreases. So therefore mu of blue color is greater than mu for red one. Mu for blue is greater than mu for red. So as this is blue color, so for blue color what will happen? Refractive index will be more, for red it will be less, because wavelength of red color is more. Got it? Yes, note down. Next one, angular dispersion. Angular dispersion. Angular dispersion. So for that I am drawing one diagram. You just see here. This is a prism. And now this is going to split into white colors. This white light is going to split into constituent colors, not white colors. Okay, something like this. Okay. So this is red and red to violet. And if we will see this one, this is the incident ray like this. And this angle is what? Angle of deviation, delta. That is for red color. This is for red color. And if we will see this one, this angle, this is what delta of V for violet color. Okay, right? Now, angular dispersion is what? So in this angular dispersion theta is equal to delta V minus delta R. Delta V minus delta R. You can keep it here capital R. Okay, this is what angular displacement. Next one is what is dispersive power. If we will see in this case, what is the dispersive power? Dispersive power. This angular dispersion is divided by theta. So you can keep it in a box. Okay. And dispersive power is denoted by omega. And what is the formula for this omega? Omega is equal to delta V minus delta R divided by delta. Delta V minus delta R by delta. This is for violet color, not for any other. Okay, this is delta V for violet color. And what is this delta then? What is the delta? Where delta is mean deviation, where delta is mean deviation, that is of yellow ray, that is of yellow ray. This is what mean deviation. If whenever you want to find this dispersive power, this formula you will use. Next one, what is delta V and delta R? So delta V is equal to mu V minus 1 into A. Next one, delta R is equal to mu R minus 1 into A. This all for small angle prism. Okay. And then omega, that implies omega is equal to mu V minus mu R divided by mu Y minus 1. What is mu Y here? Where mu Y is equal to mu V minus mu R divided by 2. Right? This is for angular dispersion and dispersive power. Please note down. Okay, finished. So let's move ahead. Next concept is dispersion without deviation. Dispersion without deviation. Dispersion without deviation. So what is this? Dispersion without deviation. Let's see. So first what I am doing, I am drawing a prism. And this one is another prism which we have placed inverted like this. Okay, so that we will get no deviation. So what is happening here? See, this angle is angle A of the first prism, and this angle is A dash for the second prism or inverted prism. Now as we are incidenting light, first when we are incidenting this light, it is going to split into two constituent colors after refraction. This is first one, this is second one. Okay, and then again it is deviating like this, and this one will deviate like this. And this way like this. So what happened here? See, this is now here. This one is red one and violet one. This is red and this one is violet. So here it will come as a violet, up and down it is a red, right? And whatever this is their ray, this is what your actual ray. Okay, let's do it with the white color. This one I'm denoting with dotted lines. This is actual path, and this is red color first from the first prism. Then after that, this is like this, so it will go parallel, and there is no deviation. So what is there here? Suppose delta is deviation by first prism, and delta dash is deviation by second prism. Okay, by first prism, and then this is second prism. Now for deviation to be zero, what is the condition? For deviation to be zero, delta plus delta dash is equal to 0. And the delta is what you know, mu minus 1 into A plus mu dash minus 1 into A dash is equal to 0. Right. So this angle is A, this angle is A dash. And for this prism, you are having refractive index mu. And for this prism, you are having refractive index mu dash. Keep it in mind. So now after this, I am transferring this term here. So mu minus 1 into A is equal to minus mu dash minus 1 into A. So this A and this A will get cancelled. No, this is A dash, no? Oh, 1 minute. So this will not get cancelled because this is A dash. So not like this. So here it is mu minus 1 into A is equal to minus mu dash minus 1 into a dash. Okay, so now I want a dash, so just transfer this term here. So you will get a dash is equal to mu minus 1 into a divided by this minus is here, I am keeping mu dash minus 1. Okay, so that angle should be there for the prism, so that we will get no deviation. Okay, and negative sign indicates negative sign indicates a dash has to keep inverted. A dash has to keep inverted. And if suppose you want here angular dispersion, that is theta is equal to delta into omega minus omega dash. Angular dispersion theta is equal to delta into omega minus omega dash. Okay, so this is what dispersion without deviation. So note down this all. Okay, okay, so let's stop here for today. Bye.